Yeah, let me begin. Let me start, and after that, I will give the session to Dr. Ben Harris. All right. Good morning, everyone. It's a lovely Friday morning in Jakarta, and good evening in Boston to Kate and also Dr. Ben Harris. I'm Yudo Anggoro, the director of the MBA program in Jakarta campus of the SBM ITB. And this is, as I mentioned before, is a series of a guest lecture from Boston University, our university partner. And this is the third series. Yeah, the first one we discussed about the supply chain logistics, and the second we discussed about the financials, the financial technology. And today we are going to discuss about the implementation of business analytics, something that we need to learn further because now it seems that everybody is talking about this, but sometimes we feel that we have kind of a lack of understanding, lack of knowledge in this area as well. And as I mentioned before, since last year, we established our laboratory of big data and social simulation, doing research in data analytics, machine learning, and stuff, right? And yeah, today we are going to have a lecture from Dr. Ben Harris. Thank you so much, Dr. Ben Harris, for coming and to spare your time, night time there in Boston. And this guest lecture, in this guest lecture series, let me just greet some of our students here. We have Mas Innovator. Good morning, Mas Innovator. He works for Siemens, if I'm not mistaken, Mas Innovator. So the students that we have that we invite to come to the session mostly are those who are working. Yeah, so they work for energy company, they work for Siemens as Mas Innovator there, they work for other industry. Basically, it gives us like a glimpse that the business, and the industry here kind of need new approach in doing their business, and business analytics seems to be one of the directions they need to go. All right, so yeah, without further ado, let's just give a warm applause to Dr. Ben Harris. Yeah, and Ben, the time is yours. Thank you so much.
All right, well, thank you very much for having me. I'm glad to be here. Glad to get to share with you folks. I'll share my screen, and you can I'll kind of walk you through what I hope to talk to you about this evening, and give you a little background on me, on Boston, on how we see business analytics as a field defined and then implemented in the corporate world. So I'll just jump over to my agenda real quickly here. We're going to start. I'll give you a little bit of background on me. I come from what may be a non-traditional academic path. We'll talk about that in a moment. We'll look briefly at the history of the field of analytics, which was born out of a bunch of different things back, decades ago from the corporate environments. The next two topics are sort of the traditional ones that we think of in analytics. The first one is very common. Everyone goes into an analytics education wanting to learn algorithms and methods and tools, really. I would refer to those as the hard skills of analytics, things you have to learn computationally, technically, to do this well. But the thing that companies and academicians are figuring out right now is that to do analytics well, you need something to go with your technical skills. You need the soft skills. You need the ability to interact with people, to ask good questions. Without the two of them working together, implementation is very difficult. So at the end of the presentation today, we're going to talk about how they work in the context of a business, right? How do you implement this process to actually affect change within an organization? And this takes practice. It's an iterative process, but let's get into some of the details and we'll walk through it together. So who am I, right? My name's Professor Benjamin Harris. I live in Boston, Massachusetts, in the United States. So it's just the end of our evening here, and I know a beautiful morning over in Jakarta. I'm an engineer by training, right? I'm a very technically minded engineer. Industrial engineering was my background. I did all my degrees there. Since 2009, I worked at a large technology company called Raytheon, initially in the engineering directorate. So I got used to how big companies worked, right? I worked as a small gear in a very big machine, was sort of how I would phrase it. But the end of my career there, the last job I had was moving away from the pure engineering and into how we did business, right? How does Raytheon Technologies execute contracts? How do we deal with customers? And using my data background to sort of make headway in that direction, right? How do you, I was able to change a very legacy traditional, lunchtime meeting organization into one that was data driven and used information to make decisions. So that was my industrial experience. One of my last roles there was defining how the company underwent what we call a digital transformation, right? How do you go from traditional processes that are done from person to person, moving into the digital world? How do you move a company into the 21st century, which is, for anyone who's worked at a large company, can attest that is a challenging problem to solve. So how did we do that? That was the last job that I had prior to leaving industry, and I joined Boston University in 2020. So I've been here for a couple of years now. My initial experiences have been during the COVID pandemic that we've all experienced in one form or another. So we're thankful that to get hopefully be moving beyond this at some point soon. So I wanted to talk a bit about the history, because if we're to understand kind of where data, where analytics is in the present day, we need to know a little bit about where we came from. What are some of the original roots of analytics, of data analysis, data mining? How did we get there? So the general literature divides analytics history into several different eras. We would call them 1.0, 2.0, 3.0. Analytics 1.0 was the very beginning of using data to make decisions. And this, at least the information I could find, started all the way back in the 1960s and 70s with the development of databases, right? And that's a technology we sort of take for granted, right? That if you have to store data in a big data context, that you have a system and a technology built to allow you to do that and access the data quickly. But that was not always the case. Can you imagine running a multinational corporation with data written on sheets of paper or in some other format that was not easily accessible? That really limited people's ability to make decisions based on anything computational. So in the late 70s, some engineers led by a guy named Edgar Codd invented what we know as relational databases, and that kicked off analytics 1.0, right? That was the database was the original aggregation and analytical toolkit that we used. But the goal back then, way back in the 1960s and 70s, at least in the United States, was on operational efficiency. The goal for every company was to use data to do things better, faster, cheaper, stronger, whatever superlative you want to use, just make it fast and make it cheap. Now, we've moved into a more sophisticated version of that with the later eras. Analytics 2.0 was the concept that came along next, and that had to do with what we would call the big data era. Now, big data is still filtering its way across the world in various contexts. People are working with new big data technologies. Something to keep in mind, though, whenever you talk about big data, it doesn't necessarily refer to the size of the data that you have, right? You can have a small database or a large database. The implementation of big data depends on the technologies that you're using to access it. So systems like Hadoop, Hadoop, or Apache Spark or Cassandra or Kafka, all these names you might run into online, are the technologies that allow us to deal with data at a nearly unlimited scale, right? So most of the technologies we use today, video streaming services, audio streaming, satellite-based communications, the vast majority of them run on these new technologies because they have to pipe immense amounts of data very quickly over some very sparse environments. And so Analytics 2.0 was the moment in which people realized that data sitting in databases was growing faster than the databases could grow, right? They couldn't keep up with the flow of data. And so rather than be constrained, these new technologies were invented in order to enable things that were previously unavailable to them. Another innovation that came along with that was something called NoSQL. So original databases could only deal with relational data, right? Anything you could put in rows, columns. If you could picture it on a Microsoft Excel spreadsheet, that was a relational database. But a technology like NoSQL allows you to deal with what is estimated to be 80% of the data on the planet, which is all what we call unstructured. So when you're dealing with audio or video files or movies or free text, none of that fits cleanly into a row column kind of organization. So how do we do it? We needed a new technology, and NoSQL was the one of the original technologies that came to help us deal with that. So that put us into Analytics 2.0. Another technology that went with that was the concept of computing in the cloud. Now, the cloud was a technology that essentially removed the requirement for local storage. You could access data from anywhere, right? And this was a novel concept in the early 2000s, probably 2005, 2006. So companies like Salesforce, actually, so Salesforce is a customer management company in the United States, were some of the first to put technologies up into the cloud. But now everyone's doing it. If you use Amazon, I believe Zoom, the system we're talking on right now, is oriented and hosted in the cloud. So we use it even if we don't know it, nearly ubiquitously around the world. Now, because data was getting large, new methods had to be created to deal with the size of the data. So things like machine learning, and the history of machine learning is those algorithms that we use in machine learning existed well before the 2000s. Those existed in the 1960s and 1970s. The shortcoming is we didn't have computers fast enough to learn anything about them. We couldn't do model training. We couldn't do in-depth analysis. It was only once computers began to speed up that we could use machine learning at scale. And that didn't happen until the 2000s. So Analytics 2.0 closed with it actually hasn't closed yet, I would say, but it reached sort of its conclusion with the implementation of machine learning at scale, which is what we experience largely today. Where we find ourselves today, though, we've moved even a little bit beyond the big data era in some places. We've moved into what we call the era of the data-enriched offering. Now, this is an era in which almost everything we use creates data, right? When your cell phone creates data, maybe your smartwatch, right? I have a watch in my hand that creates some information about me. Almost nearly any item we use leaves a data trail that can be used to generate improved decisions or personalized outcomes. So we're using data to change how we view the world in the data-enriched offering. Analytics 3.0 is the first time that actual companies have been able to survive and sustain solely based on the data that they possess, right? They possess data that is of value to a customer base. That is new in Analytics 3.0. So we're seeing companies like that. Some interesting things that we've seen based on this are technologies like blockchain. So blockchain was not possible before the global cloud systems, right? We needed the ability to have transactions stored on multiple computers around the world in order to do that. So machine learning used to need to call up Amazon or Microsoft or some other computing company and rent space on the large computer in order to do machine learning computation. Now your cell phone can do it. So I have my cell phone just here. Most modern cell phones will do machine learning models directly on the device. That is a new paradigm, and it saves a lot of computation time and effort. So companies are getting smarter with that. Now, what you should notice in Analytics 3.0 is that your experience of the world becomes more personal to you based on the data that is creating that personalization. Companies are figuring out how to use that faster and faster every day. So that's a little bit of the history, and it brings us up to sort of where we find ourselves today. The caveat I should give is that not every industry and not every company is at any certain point in this analytics continuum, right? Some companies are advanced and some are just beginning their analytics journey. And so that gives opportunity for enterprising students in MBA programs or analytics programs to find a place that they like and begin to apply these things. You can always push a company ahead down this road. What this describes here in the history is just the leading edge, right? But many companies are still working their way up. Now, I'm going to transition briefly to the hard skills. So when students of mine enroll in the business analytics program at Boston University, oftentimes the thing I get asked most often is, okay, Professor Harris going to take your class. What skills am I going to learn? What algorithms and methods are you going to teach me? And we do go through a lot of those tools and methods. But that is all that they are. Those are tools and methods. What we start with in most courses and what we try and end with in most projects is beginning by asking the right questions, right? When you approach an analytics problem, probably the first 20% of the time you spend on the problem should be talking to people, right? Understanding what do they need, what data is available, what do you want to try and do with it, what value are you going to create with it. If you don't have those questions right, it really doesn't matter what methods you know or use, you're not going to be delivering value. So we always begin with questions. So this is a slide from our foundational analytics course that points out, okay, here are the types of things you can do, but we want to think of these as tools. So the kinds of analytics we have available to us are descriptive, which just is describing what is happening, what has happened in the historical data. We use visualization and dashboards here. And some students, when I talk to them, they're not enamored with descriptive analytics, but what I tell them is probably the most value you're going to find with a company that is new to analytics is in this area. All that they need to know to start is, how does my data relate to itself, right? What relationships do I find? What correlations do I observe? And how do I deliver value from that? So you don't have to go all that fancy or complicated to deliver value. Descriptive analytics will usually get you there fairly quickly. We also have predictive analytics. This is things like forecasting and regression. It's trying to understand relationships and make a prediction as to what will happen in the future. Now, you can probably think of some contexts where this is important. Maybe you want to know, are automobile prices or housing prices going to rise or fall? So you develop a model that gives you some version of a forecast, right? You try and extrapolate a relationship out into the future and see what happens. That is helpful. What I always try to remind students in those tools is that any forecast is exactly that. It's only a forecast, right? It's a looking to the future. And the key to doing predictive analytics well is understanding the weakness and limitations of your models, right? Because if I were to tell you that I can predict the average housing price in Jakarta in 2023, you would laugh at me, right? Because I don't have that computational ability, right? It's a forecast. It's going to have some error in it. And we need to be honest about the analysis that we do. The third, probably the most sophisticated methods that we use are called the prescriptive methods. Once you know what has happened, what might happen or will happen in the future, the question that companies are always wondering is, what do I do about it? What decisions can I make? What problems can I solve in order to optimize my outcomes? This is where prescriptive analytics comes in. The field of operations research is the umbrella that sort of sits over prescriptive analytics. And it gives us a lot of very powerful tools to work through decision theory problems, to analyze what a company should do under any set of circumstances. So that's what we cover in the foundational courses. But the thing we try and remind people of is that all of these things are just tools in a tool belt, right? They are not value added in and of themselves. So if you can imagine putting on a tool belt and walking into a job site, what you should do, and what to me denotes wisdom as an analyst, is if you choose the right tool for the right job, right? That we don't get enamored with something that just happens to be our favorite. So the thing that enables us to use them well is asking good questions. And we're gonna, at the end of this presentation, we're gonna walk through just a short slide on an example of questions you might ask in order to get to something that you can deliver analytical value from. But you're gonna hear me keep coming back to questions, because to be a good analyst, you need to be curious and willing to ask repeated questions to get to the truth of things. You're trying to understand, what is the real root issue that I'm going to try and use data to solve. In most of these analytics references, questions come first. We need to begin and end with questions. I also want to give us a bit of a view on how analytics is done within a company, right? The last slide we talked a bit about the rough categorization of hard skills. We also want to talk about some of the soft skills. And if you were to join any company that does analytics with any regularity, what you're probably going to find is that analytics is what we would call a team sport, right? Everyone comes in with tools that they're good at, questions they're asking, value they're trying to add, but the process of analytics is almost never done alone. There's different groups of people involved in the process within any given company. And a number of resources have sort of categorized these in 4 different groups. You have investors, practitioners, directors, and consumers. They are all necessary for sustainable analytics, and we'll talk about them briefly here. So You may have never thought that when you do analytics, you need someone called an investor. Why do you need an investor? It comes from a raw economic reality that in large part, when you perform analytics, you are not adding direct profit to a company just by doing your analysis, right? You're analyzing data, developing relationships, but then the reliance to develop value oftentimes falls to other people, right? So you're not creating products normally. You're helping people understand how to respond and react to markets better, how to develop products and supply chains that are more effective. You're not in and of yourself developing value. So an investor within a company that invests in analytics has to understand the value that the analytical models are bringing in order to devote resources and time and people to doing that kind of work. So most of the time when analysts go to join a company, you don't usually start in this kind of a role, right? Oftentimes the investor role is reserved for people who have experience in analytics, or maybe they have a great understanding of the business. They can understand that if I had an answer to this particular question, that's of great value to me, and I think an analytical model can get it for me. If people understand that, they can work as an investor. So what the investors do is they sponsor the analytical work within a company. Now that could mean hiring people, analysts, or providing equipment. Oftentimes it's the computational power needed to do these analytical models. But that is a critical group of people to make analytics work and be sustainable. The second group of people this is probably who you would begin working with within any given company doing analytics. These are the practitioners. So practitioners are those who primarily lead and they do the analysis. Excuse me one moment. So if you take up a job with the title analyst, analyst 1, analyst 2, analyst 3, you would probably find yourself in a practitioner group, largely learning from more experienced practitioners. But in doing so, the hope is that you're going to gain intuition as you go, because what you'll find with any time in the analytics world is that people enter into this world with very different backgrounds. So our ABA program at Boston University has students coming in from all manner of backgrounds. Some have a computer science background. Others have a background in film studies or social sciences or psychology. And they just decided, hey, we'd like to get into the data field. And our program is designed to bring them into that from really any background. But each of those people have a different set of skills and intuitions that they bring to data analysis. And the truth is we can all, those of us in analytics can learn from one another, given that our perspectives are so different. So never think badly of someone who doesn't have the same pedigree or background. They just may see the world very differently than you. And the data can help, the combination of the two of you and data can be very effective in delivering value. So oftentimes when people begin a career as a practitioner, they may transition to other kinds of roles within a company in analytics. Probably the most common transition is going from a practitioner to what we would refer to as a director. Now, directors are those people who lead the analytics practitioners. So if you join a company as an analyst, you're probably going to have a manager. Now, the managers of analytics folks usually are ex-analysts themselves. They had worked as analysts, and they develop some expertise on some aspect of a business, or they have a strategic vision in how to analyze data to be effectual for a company. Directors tend to be the day-to-day managers for analysts or analytics experts. But one of the other responsibilities they have is to sell analytics across an organization. Now, we would hope that data analytics sells itself, right? People would look at the models and work we do and say, I want more of that, just keep giving me analytical results. But oftentimes that's not the case, right? People either are not willing to hand over data, or they maybe don't see the value or don't want to waste the time as they would see it. It's the responsibility of the directors to convince them that this is a worthwhile use of your time, right? The money and time and energy you're going to spend here is going to return orders of magnitude greater than what you've spent. So the directors sort of shoulder that responsibility for growing analytics across an organization. The last group here are consumers. So consumers are the groups of people within an organization that they eat up the analytical results that teams of analysts create. They need the answers to the questions you're answering. They maybe provide the data to you, but they need an analytics expert to create something for them. Now, consumers can be a whole, a very heterogeneous group of people, right? Consumers may be people who've never been exposed to data before, right? It's maybe someone who's worked in a factory their entire career and just needs someone to help them be more efficient. Maybe it's a finance person, maybe it's a human resources professional. There's no guarantee as who might be a consumer. Occasionally, a practitioner or a director will transition out of an analytics role into a consumer role, and that can have a real benefit, because if you have a leader or a decision maker outside of the analytics space that actually understands data, that makes your job a whole lot easier as an analyst, right? You're speaking the same language, and you can deliver value usually much faster than someone else who's never been exposed to data. So those are kind of the, if I had to look at an analytics function within a company and segment it into groups, this is probably how I would do it. Now, and I should mention that in the groupings here, in my industrial career, I've worked as 3 of the 4. I've never been a consumer, but I've worked as a practitioner, director, and an investor at various times. All right, so big data, right? Now, what is big data changing? How are we moving through the eras of data? If you, my hypothesis is that if you went to a company and you asked them, do you have data available for me to work on, to do analytics development on? Most companies would say, yes, we have plenty of data. Don't worry about it, we have you covered. The reality is most companies may not understand exactly what is needed to do effective analytics. They may think they have enough data when in fact they don't. And so it's the responsibility of an analyst to really ask good questions to help them understand, okay, you have some data, but it hasn't been cleaned, it hasn't been validated or checked. So we need to do more work before we know what we can use here. So companies would say that they have data, but they're beginning to understand the reality that they need to invest in technologies or find themselves left behind, right, within the industrial environment. We looked at a few of the eras here. We'll just see what, we look at our little diagram on the left moving up, right? The original Analytics 1.0 was data mining, right? That was looking for patterns and predictions. But from there, we moved into big data, and that enabled things like machine learning and streaming. Beyond that, we moved to data-enriched offerings. That's what we're seeing today. So personalized data or unstructured data analysis. So things are moving, and what you should see as that arrow goes up is the amount of data that gets attached to all of those things is growing with each era, right? The data is growing large. The graphic over there on the right is highlighting the expenditures that many US institutions are making on big data and how things are growing year over year in terms of expenditures. Right now in the US, the industry that's growing the fastest with the use of big data is the energy sector, right? We're seeing massive investments in big data to make effective predictions on network topology, on resiliency, reliability, all sorts of things, right? In the wintertime in New England, where I live here, we get some pretty nasty storms, and the energy companies are trying to make sure that the power grid stays up, and they're using big data to try and do it. But energy companies are very old legacy companies, and they're struggling to implement these big data technologies, but they're investing as best they can. But the market is still growing. It appears that the market is, all of these areas is going to continue growing for years to come. So big data is here, and it's here to stay. So in my view, it's worth it for companies to make sure that they have a good understanding of what they need to do, how to get a hold of their data to develop results that add value. Now, analytics comes alongside that, right? Having big data is wonderful, right? You have data stored in a database, but there still remains work to do in order to develop value and essentially deliver results to a corporation. Now, a number of consulting firms have started to measure how much the implementation of analytics is impacting companies. So the Bain company, this was actually a fairly old graphic now, but the relationships are still true, would mention that the companies that use analytics the best make decisions better than their competitors in a number of different areas. They tend to have good quartile performance. Their financial performance is excellent. They make decisions faster, they execute to the decisions, and they use data more often once they do it frequently. Now, those might seem like small things, but in many industries, the speed and the relevance with which you make a good decision can make or break the survival of a company, right? Whether you're going to invest in a certain area or choose not to. Oftentimes your speed is what makes or breaks that concept. So what companies are figuring out is it's not even the number of decisions that you make, but it's how you use data to make a better quality decision than anyone else, right? How are you optimally using the information that you have to make good choices? Now, this is an ideal state, right? If you use data to go through the analytics process, go through descriptive, predictive, prescriptive analytics, ideally you're going to do some of these things described in the graphic. But the question is, why don't companies all do this, right? Why is this not implemented universally? And there's a few reasons that making data or making decisions without data can cause problems for companies. It can be suboptimal. One of them could be something referred to in the slide here, is you make decisions too slow, right? I'll ask the question rhetorically to everybody on the call. Can you think of a time in a company or in school where you asked for a decision and the decision was just so slow in coming, it was kind of ineffective at that point? We probably can all think of moments in our lives where we just needed a decision made. Maybe it was for a financing or a loan of some kind, and it took way longer than we thought it should, right? So one of the things that data is doing is speeding up the decision-making process. Another reason that decisions without data might not be as optimal as we think is decisions many times are influenced by emotions and bias. So when we refer to legacy companies or legacy organizations, one of the connotations of that is that decisions made in these companies are made using the traditional methods that companies have always used. Right? If you think about a financial firm or a manufacturing company, they may make decisions based on the way they've always done it. Right? That's a traditional, or that's a human tendency, is to know that we've made a decision one way and it's usually worked, and so we're going to continue. So when you bring in data that says we should actually make a different decision, there's a natural resistance to that, right? We tend to be risk averse with decisions that really matter. So, so without data to support things, humans tend to fall back to their emotions and biases when making choices. And one of the last reasons that we're going to take a look at is, without data, some of the decisions you make may be too simple for the scenario that you're encountering. Right? Oftentimes, decisions we make in large scales are complex. Right? There's more than one factor, more than one variable associated with the choice. But the human mind can only handle so many variables at a time. I think the psychological literature mentions that if you asked people to remember numbers, right? If you gave people a string of numbers to memorize, the human brain for most people is only capable of remembering between 6 and 8 numbers at a time. Beyond that, our memory starts to fade and be less reliable. So if you asked a person to make a decision based on 10 or 20 or more variables, the likelihood of them making a good decision is almost zero, right? Our brains just are not wired to handle that level of information. But analytics techniques have been built for that very purpose, is that you can take complex decisions, make the decisions quickly, remove the bias and emotion from them, and handle the entirety of the complexity of the choice when you make it using analytics. So that's the power of the tools that get you there. Now, it's important to realize that they're just tools. You need to have the right question, the right data, and the right value outcome. Another topic that's helpful to think about here, beyond sort of the tools, the soft skills, is the fact that different companies structure their analytics differently, right? You have a couple different models of analytics applications that you might see in a company. And I would roughly categorize them 3 ways. So an analytics function can be what we would call centralized, meaning if you go to a large company, there's an analytics office, there's an analytics director, and each of the business units within the company has an assigned analytics person. But those people all report to the central analytics function. They report to the director of analytics. You can, if you were to draw that on a whiteboard, you might see sort of a spoke and wheel kind of diagram like that. So that's a fairly common way to see an analytics team structured. The opposite view of that is what we would call a decentralized analytics organization. You can think of that more as a spider web. Now, companies that operate under that paradigm have analytics people that are embedded within specific functions of a company. So for example, you'd have an analytics expert within the finance team. You'd have an analytics expert on the human resources side, or the operations or the engineering team. And those people would largely be independent of any central authority. They're working for the organization that they are in, with no sort of central governance. That's called a decentralized analytics model. But there can be mixtures of those two. You can have what is sort of referred to as a hybrid model, maybe with some combination of decentralized and centralized authority for analytics. Each of those has a pro and con, though, right? Before we sort of choose the one that we like, companies choose these structures for different reasons. Now, sorry, scroll down a little too far. If a company focuses on one product area, you can probably imagine a company that really has a small product portfolio. They're probably going to have a centralized analytics function. And the advantage of that is that a company like that can share data and products easily, right? If there's a single central analytics person, you have usually a central database, central tool repository. Everybody works on the same page, right? It makes it fairly effective. The downside to that is that the folks who are reporting to a central analytics function may have a hard time becoming experts in their area, right? They're sort of contract employees, so to speak, within a given part of a company. So you may not have a lot of expertise, but you have a very efficient analytics organization. You can contrast that with a company that has a very broad product portfolio. So if you think of a sportswear company or an apparel company who sell many different things, you're probably going to have a decentralized analytics organization, meaning that there may not be one person who's directing the analytics across the company, but each organization or business area within a company is going to have an analytics person. Now, the advantage to that is those people will pretty quickly become experts in their given analytics area. So that's a good thing to have some intuition and expertise built. The downside is that you're unlikely to have a standardized data and reporting process. There's no real governance of the data or the work that's done. But that's the trade-off that is made within companies. The one thing to note is no matter how a company structures its analytics, no matter how they implement this, you're being led by the data is one more step that you have to take. Right? Having people who do cool analysis and return good value in terms of their insights is one thing, but being led by the data is an entirely different level of trust. So being led by the data is when a company relies on the data to even construct the potentials for a decision. Right? If we could use a marketing example as a case in point here. If you're a company led by the data is going to examine user feedback and user input in order to generate what new products they should create. Instead of just thinking up what would be a cool product, they go directly to the data. What does the data tell us we need to do? And that, at least in the United States where we are, that is a rare thing to find in companies. Most companies would say they make data-driven decisions, but very few are led by the data. That's a different paradigm that we're just beginning to experience. All right. Some perspectives here. I'll give you a quick rundown of some mistakes that I have made in my analytics career, things I've done wrong, too fast, questions I didn't ask. With hopefully you guys can remember this slide, go back and watch the recording, and remember, don't make these same mistakes that Professor Harris made. I want to save you guys all the headache and the trouble of learning this the hard way. So what we define as the analytics process, no matter the tool you're going to use, is starting by understanding the business problem you're trying to solve. Now, oftentimes this is ignored, right? People, they just ignore the reality that you need to be solving a business problem and not doing the coolest analysis that you think you can do. There has to be a business end here. So oftentimes this isn't done, and when it is done, it's not done very effectively. So make sure you start there. Once you've done that, and only after you've done that, you want to choose the right tool, right? Once you have the problem in hand, you want to ask yourself, what is the most effective tool for using or to to complete this analysis. Sometimes the tool is not the fanciest and most sophisticated tool. Oftentimes the right tool depends on your audience, right? If your audience is looking to take in data insights, sometimes having a deep learning or a machine learning or an AI-driven model is not the best way to do it because it's not very trustworthy to most people. So the right tool is an important thing to realize and to focus on. Now, only after you've done those two things can you really deliver value in analytics, right? You have to know the business problem you're solving, the right tool to provide insights on, and then the value will begin to flow at that point. Now, some pitfalls here. This is where things can go wrong, and I bring these up mostly from my experience. So, one of the original pitfalls is an obsession with an algorithm. If you pay attention to the analytics literature as it comes out in journals and articles and things like that, there's always a new algorithm that's coming out, and it becomes the rage for about a year, and then someone comes out with a newer algorithm. Now, the problem with doing that is that you're not guaranteed to have the right tool for the right problem. So it ends up looking something like this, right? You have a screw to put into a piece of wood, but that is the wrong tool to be using for putting the screw into the piece of wood. So obsession with algorithms really usually doesn't end in good value for anybody involved. So we want to, we might think our algorithm's really cool, it performs better than others, but hold it in your tool belt like anything else. Another thing that causes pitfalls in implementation here is not looking at data quality. From my years of doing this in industry and also in academia, I can count on one hand the number of times that I've received a data set that doesn't require any cleaning or adjustment. That's it. And I've probably worked on several hundred analytics projects. So it is very rare that data is all that cleaned. So the first question you should ask when receiving data is, how good is this data? Is it clean? Is it, was this input by hand by people? If that's the case, it's probably contains errors. We just need to know that, recognize it, and try and clean it. Another pitfall that people can make when implementing analytics is failure to understand what your customer desires, right? This comes from the questions that you ask, right? Understanding the desires of a customer. So this might be questions like, how complex of a model do you want? How much data do you have? Are you able to get more data, right? When you understand what the customer is looking for, that oftentimes will tell you what tool you should use. So asking questions will get you there to solve that problem. And the last one is sort of related to the previous one, is if you don't assess what we would call customer data maturity. So right now, one of the courses I'm teaching is what we call a capstone project. And the capstone projects involve doing an analytics project with a sponsor company in the Boston area, usually. And so the sponsors that we interact with have varying levels of data maturity. Some are very familiar with data, others have never seen a spreadsheet in their lives. And so when we understand that, that changes the deliverable that we give to them. So if you show to someone who's never seen data, the output of a machine learning model, they'd probably be impressed with your mathematical skills, but they wouldn't know what to do with the results you gave them. So what you've done is you've shown yourself to be very intelligent, but we haven't delivered very much value yet. So data assessment of maturity is very, very important to make this effective. Now, I've mentioned it a few times, but the path forward here is to ask questions. Right? How do you collect this information? You need to begin to interact with people. One of the methods that we use most often is called the 5 whys method. And this comes from the business school literature. And it is simple at its core, but it is effective to this day. So what I wanted to do is I'll walk us through just a brief example of how this might look within a company. When we ask questions, it might look something like this. Maybe you go to the CEO or a C-suite leader and you ask them what keeps them up at night, right? What worries you, what troubles you? And they say, we're not selling enough products, right? Our sales are down, our profits are down concurrently. So your right response is to ask them, well, why? Why aren't you selling products? Maybe the customers say they're too expensive, right? It's a fairly common complaint amongst many high-tech products. You need to follow up again and say, why? Why are your products too expensive? Well, it costs a lot of money to produce them, right? Okay, that might be true, but why? Right? Why does it cost so much to produce the products we have? well, the raw materials we use are very expensive. It's hard to get microchips. It's hard to get aluminum or steel. And so you probably see the pattern here. You want to continue moving on, asking why. Raw materials are expensive. Why? And at that point, they might give you the final answer that might be more helpful. Well, we have a specific part that we only get from one supplier, right? That sort of is hitting on a core or a root issue. So one more question is, why do you only get things from one supplier? At that point, you might ask another why and continue on, but to me, when you hear these answers, this sounds like a good opportunity for something like supply chain analytics, right? Using data to examine, okay, how did we get ourselves in this problem, and how can we get ourselves out, right? How do we fix this? So things you could do, right? You could use data to look at, take market data to look for additional suppliers, right? Hopefully there's more than one company that produces the product you're making. If not, it's a very risky product design, right? If your product is dependent on the behavior and production of a single company, that is a risky supply chain. You could use descriptive analytics to estimate the supply chain impact, right? If you begin to expand your market presence and say, okay, we were buying microchips from one company, but now we're going to actually source them from 3, right? That makes our supply chain more complex, but it also may drive the price down, right? So that might be a helpful thing. You could use predictive analytics to estimate the new cost of the product, right? And that'll give you a return on investment for your analytics dollars, right? If you see the cost going down to the product, hopefully the sales will go up by some projection, and you've solved your problem on the front end, which would be great. And lastly, you might use prescriptive analytics to define how many of these products you should produce with the new materials, making the production decisions as you would need to make them in that new scenario. So the point of this small example here is just to highlight that asking questions, asking why a bunch of times, can actually get you to some very valuable insights that now you can go find data to support and develop new decisions and new insights for a company. So this, I know a close family member of mine who's an engineering vice president, and he's the best person I know at doing this, right? He's got this process down to a science, and he would attest that he's found most of his career success by solving problems in exactly this way. Just ask questions. Okay. Last slide I really want to talk about here is kind of the summing up slide of all the things we've talked about so far. Now, business analytics is a bunch of different definitions, but one that I find helpful is it's the combination between value architecture and data science, right? And the reason we separate it that way, we can make this fairly simple. So data science is really going to be the hard skills that you gain. It's all the tools you put in the tool belt. Understanding how to deal with certain kinds of data, do different kinds of models. You need some communication skills, so maybe you wrap those around your hard skills. But what goes with that is understanding change management. How do you affect change within a company? How do you build credibility and trust in the analytics models and work you're doing? That is what we would call value architecture. Now, those are more akin to the soft skills with a good deal of business understanding, right? That's how we develop value here. Now, the reason I colored those two boxes that way is because those line up with the diagram on the right there. That's sort of what we would call the business analytics cycle. So every time you're able to ask a bunch of questions and establish a value proposition, right? Something you can tell to a company that if you're able to solve this problem, this is what I would estimate the benefit to you to be. You can go through this process to use data to drive a decision. So you go to the data science tools, define the problem you're solving, develop a hypothesis, and test it using the data, right? That's the analytics or the data science hard skills process. Once you've done that, now the real work begins. You're going to take the value and the insights you've built, show them to people who care, and make sure you can deliver and measure what you've done, right? So this is a cyclical process, and it ties together all the things that we've talked about in the last 45 minutes or so. Is using your person-to-person skills, asking questions, trying to understand the cares and desires of your consumers, and then using your data and technical skills to bring people the insights that they need. That's what really builds effective business analytics, right? And it's something that is learned over time, right? So analysts don't become great analysts overnight. They take several years, oftentimes, to develop intuition, to develop technical proficiency to the level that is really helpful. But once they get there, these analysts become change agents that can really impact the trajectory of an entire company, right? That's why companies that focus on data do so well, is because they're using it to drive their decisions more optimally. So, all right. So I think I'm just about hitting my time point at the end of the hour. So those slides were just a brief walkthrough through the analytics history that we define, some of the hard skills that we teach in an analytics program, but also some of the soft skills that you need to bring and have developed through project work. And how do those things work together? How do you actually do this within a company? So anyways, I hope that was insightful. It's a mix of academic theory that I teach and some experiences with successes and failures in business that I've experienced. So yeah, so with that, I'll conclude and thank everybody for your attention. And I'll open the floor to any questions as they might come in.
Thank you so much, Prof. Harris. And yeah, very nice lecture. Yeah, so you explained about the analytics 1.0, 2.0, 3.0, and finally coming with the pitfalls. And the business analytics is consisting of value architecture and data science. And I believe we have some questions here already in the chat box. And wait, let me just go to Elivina. She works for Pfizer and asking about her experience in doing data science there. Mbak Elivina, you want to ask the question yourself? Go on.
Okay, thank you, Pak Yudo. Okay, so good morning, Sir Benjamin. So yeah, good morning. My name is Elivina Mirdiani, and I work on Pfizer as a commercial effectiveness lead. So I've been leading part of the digital transformation, especially in terms of Salesforce effectiveness. So based on my experience, I do agree that the data quality is actually the first key to have the best result of the analytics. But we cannot avoid that when the users are entering their data, it might result in junk files, and somehow we are in the head office cannot really differentiate what's the real data that they really need, and which one of the data that considered as the junk files. So may I have your best practice of doing the data cleansing, so we have the clean data to work on to get the best result of the analytics. Thank you.
And thank you for your question. So if I understand your question correctly, I think I guess a best practice that I would use is if you can, defining a I guess I would call it a data validation scheme. I actually I use what is built up as what they call a test suite in software engineering. So for each of the, if you look at a relational database, for example, and you have the data columns that are contained and they're maybe filled out by users. At the beginning, when you construct a database, you can define what kind of data can go into each of the columns, right? So you have a validation definition there, and that's a first sort of check that you have. But every so often, you have to go back sort of manually and check, I guess, data validation that may have passed, but is still sort of a junk file, as you described. Usually that's the result of text, right? And people put in text and it just is not helpful to anybody. So the other thing that I do in that circumstance, especially in a big data environment, is use ideas from what we would call statistical sampling. So for example, if you're examining aircraft parts, for example, on a production line, you can't examine all of them, right? It's just too time consuming. And so you can use statistics to create a sampling plan of randomly pulling out 2 data points that hopefully you're going to validate as a representative for the rest of the big data set. And so now that there's a pro and a con to that, in that you're not guaranteed to get a perfectly clean data set, right? Because you could still miss things. But with the amount of time you'll spend validating, there's a good chance that you'll do better than you would if you had to by hand examine each of the data points in your big data system. So statistical sampling can speed it up, but it's a heuristic method at best, right? You can't guarantee that it's completely accurate. Yeah, I think. Let's see. Does that sort of answer some of your question?
Thank you so much, Sir Benji. So, if I may also ask, I also experienced using machine learning as a way to clean up the data. So, but I still have to get to the user to do the validation check for me before I execute it on the final result. And it quite takes some time as well. So,
I bet.
yeah, yeah, I agree. So yeah, perhaps is what kind of other way that we can implement from doing the machine learning? Is it always need to get the user validation first, or is there any way that we can clean up the data without going through the user validation? Thank you.
That's a good practical question. So I would say yes, and one way you can move towards that is this will take some building of credibility and trust on the part of the company. If you use a machine learning technique to do classification or regression based on what you're looking at, what you might do is define a risk threshold that the company is willing to accept. If you use machine learning to predict what's the likelihood that this is correct or incorrect, and if a new data example, you put it through your classifier model and it shows it exceeds the threshold, seems pretty correct. You as a company can ignore that. Maybe you don't need to have the user come in and validate that for you. But what that takes is some trust from the company, because you're asking them to say, okay, these are data examples that nobody has looked at, but our machine learning model predicts that they're 95% chance of being correct, right? So that has to do with the soft skills we were talking about earlier, is convincing management that the method I'm proposing is good enough, right? It eliminates 95% or more of errors, and it takes no time from the user, right? So you can approach it in that direction of setting up a tripwire, if you want to think about it that way, that if an example is good enough, you don't need to check it.
Okay, thank you so much.
Right, sure.
Thank you so much, Elifina. Next, we have Mariani. Mariani also has experience in implementing the big data. Go on, Mariani. And where do you work, Mariani?
I work in a travel company, Pak Yudo.
Travel company. Okay,
yes,
go ahead.
Travel company. Okay, good morning, everyone, Pak Yudo, and good afternoon, Dr. Harris. I believe it's already PM in your location. Okay. First of all, I really like this course you're sharing with us, because in my current company, we haven't used any data analytics just yet to make decision. So thank you for being able to share it with us, and thank you, Pak Yudo and SBM ITB for providing it. So my question would be, we're talking about data analytics, right? So we're looking for the past data or events, and we're working start from the problem secured. But what do you think in this digitalization era, as we know, and especially for services company like mine, the consumer behavior is changing rapidly, and they become tougher right now. Can you share your opinion with us regarding the connection between data analytics and data prediction for future steps? And the second question would be, is it still relevant to use data analytics from 5 years ago? Since now in this VUCA era, the situation changing very, very fast right now. So is it the data collection will be lesser time, or what, Dr. Harris? Thank you.
All right, so great questions. Thank you. I'll rephrase them for just a moment, make sure I understand them completely. So
yes.
So the first question, is it you're asking, is it how do we make a prediction on user or consumer behavior? Right, you're trying to use data to predict what people will do. Is that right?
Yes. Is there any connection between data analytics and data prediction to make a better decision?
Yes, and so I'll give one example. This might have to do with, this is one of the courses that I teach, that we teach a course called Web Analytics, and one of the tools and techniques we use is called web experimentation. And it's, so in a web system where when we observe, people who come to a website and they spend a certain amount of time on a page, and maybe they, you think about a marketplace or an e-commerce website, they go to the buy page and they purchase a product. That's great. And the question is, what behaviors did they make in order to get there? And so experimentation is an analytics technique that tries to induce increased behavior for those goals, right? We want to make people purchase more products. And so that's, we do use data analytics to try and assess the likelihood of improving outcomes in that kind of a way. The example I would give is, so we use Amazon.com in the United States a lot, and an early version of the website had the purchase button way down on the bottom of the web page, way hard to find, actually, hard to see. If you go to Amazon today, the buy button is right at the very top of the web page, easy to find, right? And so this was just a simple website change that the company had used data to assess that making this simple change would result in a great deal more e-commerce throughput. So the one word answer to your first question is yes, that analytics does connect with user behavior. We want to be honest, though, that it's humans are still humans, that they never behave completely predictably, right? So the best we can expect when we use analytics to be predictive, in that sense, is an estimate. We think it's going to get 10% better based on this change that we made. So that's a caveat to give to your company, to say, we're going to make an improvement, but it's only an estimate. We're gonna measure this as we go through, right? You want to continually do better. Now, I appreciate your second question too. Is it relevant to use data analytics from 5 years ago, or the time of the data collection that may or may not be relevant anymore, right? Is old data still relevant? I guess is how I would phrase that question. My answer is it can be. It depends on, to me, what it depends on is how frequently that data comes in. So if you were receiving, data once a month on the first day of every month, then 5-year-old data might be just fine, right? Because you'd have 60 data points that would get you to today. So that's not too bad. But if you were receiving data minute by minute, right? Every minute you're getting data points. 5 years is a long time ago, right? So you can, in your particular circumstance, you can assess how many are the processes that made the data still the same. So if it's a monthly data process, they might be the same. They might be just fine. But if it's, I'll go back to the minute by minute example. If the data changes every minute, there's a good chance that your process has changed. And so the old data is not relevant anymore.
Okay. Thank you so much, Dr. Harris and ITB.
All right. Thank you so much, Riani, and also Professor Harris, for the answer and also the entire lecture from you. And I think that concludes our session today. And I like your quote, human is always human. Yeah, what we can do is only to make an estimate, even though we have used the advanced data analytics, but well, we are still human after all. There are many factors out there and we can only make just estimate. All right, participants, students, colleagues, let's just give a warm applause for Professor Benjamin Harris for his inspiring lecture to us. And I believe this is not the last, Dr. Harris. Hopefully, for the next session, we can invite you more to give a lecture in our MBA program in SBM ITB in Indonesia. All right. So before we conclude this session, I believe we have a token of appreciation that have been prepared by our team. Mas Guru, Mbak Arisa.
Yes, Pak Yudo. We do have.
And we're going to have a photo session after this. Oh, wow. different haircut there, but hopefully you look you like that picture, Dr. Harris. All right, thank you so much again, one more for your sharing. And before we close, thank you again, Kate, for arranging this session as well. Let's have a group picture together, shall we? Please turn on your camera so that we can make a great picture together. All right.